Good morning, everybody. We just opened up the room and we're letting people have a chance to log on. Hope you're all doing well this morning. Give it just another minute or two while people sign on. Right, that looks like it's slowing down a little bit. Good morning, Steve. Good morning, everyone, and welcome to the Florida Friendly Landscaping Professional Webinar Series. Today's webinar is Stormwater Ponds, Determining the Benefits and Best Management Practices with Dr. Eban Bean. This webinar is approved for one FFLCP, one LIAF, one FDAX, one DBPR, and one FNGLA CEU. If you haven't already signed up for the CEU, I'll put the link in the chat box during the webinar, and you can sign up afterwards. And I will be sending out those CEUs on Friday to give people a chance to register for those. While the webinar is free, there is a $15 charge for the CEU to receive that certificate. And you may have noticed your microphones have been muted, so please put any of your questions in the chat box and we'll take them at the end of this presentation. Our next webinar, we hold this series on the second Tuesday of the month at 10 o'clock. And the next one is Let's Talk About Grass, a conversation with UF turf grass experts. And that's going to be a different format where we're going to really encourage questions and have more of a round table feel to that webinar. Try something new. And you also will see a survey pop up at the during this webinar. And if you can take time to fill out that survey, we really appreciate it. And with that housekeeping, I would now like to introduce today's speaker. It's Dr. Eban Bean. He's an assistant professor and extension specialist in urban water resources engineering and is a member of the Sustainability Human Ecological Development Group. He's a member, he specializes in stormwater management, water quality and quantity issues, low impact development, sustainable urban development, and reducing non-point source pollution. Dr. Bean's research program focuses on the design, evaluation, and management of urban landscapes for our water resources and sustainability. And his extension program focuses on urban stormwater management and how design management of drainage networks can be sustainable. Dr. Bean received his PhD in agriculture and biological engineering from the University of Florida and is a licensed professional engineer. And with that, I will turn the floor over to Dr. Bean.
Thanks so much, Claire, for that introduction. It's great to be here today. It's an honor to present to you today. And I think that the topic of stormwater ponds is, it's as you'll see, it's a widespread topic here in Florida. We have them, almost everywhere, it seems like. And so I'm happy to kind of present today. Claire kind of already went over and did the introduction. So you got a little bit of background on me and where I'm coming from. Again, urban water resources engineering. So looking at how do we manage water in the urban landscape. So when we think about going into stormwater ponds, I want to kind of back up and really kind of establish a ground, a base for why we have stormwater ponds and what they're intended to do, what they're designed to do, so that you have an understanding for why is it here, why is it, look the way it is, what were some of the decisions that went into making this. So let's start off first with just the overall water balance on a site. So if we have sort of a natural site that hasn't been developed, maybe it's a forest, just conceptually here, throwing some numbers onto this pie chart, we might have about half of that water that might infiltrate into the ground that lands on that area. And maybe about 40% will either get captured by the leaves and then evaporate back into the atmosphere, or maybe infiltrate into the shallow soil, and then roots from the plant and vegetation will take it up and then put it back in as water vapor into the atmosphere. But only maybe about 10% of that water might actually run off and leave the site, okay? As we start to increase the imperviousness, so now we're looking at maybe 10 to 20% of the area has impervious cover. Think roofs, roads, sidewalks, driveways, etc. This might be sort of like, your individual sort of ranch lots that have fairly low density, low development. So in this case, we've shifted slightly the amount of water that it infiltrates. We've reduced that now to 42%, and we've increased our runoff to 20%, and our evapotranspiration's gone down a little bit. So we're reducing the amount of water that's actually going into the soil, and that's being taken up by the roots and so forth. Then as we get into sort of the more impervious cover, think of these as your more like quarter-acre residential areas, your standard lots that are being built pretty frequently nowadays. And we decrease that infiltration and evapotranspiration even further, and the runoff we bump up a little bit more. Now we're at 30%. And in our ultra downtown areas where we have really high impervious cover, we may have 75 to 100% impervious there. We have only maybe about 15% of that rainfall actually infiltrates or makes its way into the ground through limited green space and cracks in pavement and so forth. Maybe 30% is evapotranspiration, really most likely going to be just evaporation, water that ponds on the surface of impervious surfaces and then basically evaporates into the atmosphere. And now about 55% of that rainfall now basically runs off and goes into some water body or some drainage network. Now, if we look at this, it may look like, when we go from the natural ground cover to the impervious or to the highly impervious, let's say, for example, the 30 to 50% impervious. It may only seem like a 20% increase in runoff, but it's actually a threefold increase in runoff. There's 3 times as much water now that would be running off. And this is kind of looking at it from a whole average annual basis, let's say, where we're really kind of looking at all the water. And so if we take a look at what the effect is on individual storm events, we can actually see that there is a fairly complex or there's some fairly complex changes that occur in the rainfall runoff response when we increase the imperviousness. So a few things to look at here. First, this graph shows our rainfall and runoff on the vertical axis, and this is over time. So these blue bars represent the amount of rain that happens in a certain time increment, let's say 5-10 minutes. All right, so it starts out very light, gets heavier and heavier, get peak intensity, and then it tapers off over time. Well, in the undeveloped condition, that water would slowly infiltrate into the ground, filling up areas that were depressional on the surface, and then eventually contribute runoff. And it would slowly produce that runoff over the landscape and create sort of this runoff curve. When we increase the imperviousness, though, and the connection of those impervious areas, several things change here. Number one, we have an overall greater amount of runoff. We saw that in the water balances with the pie charts, right? Well, this is what we see on an individual storm event. There's also a shorter time to the peak. So this is the peak here versus the peak for the undeveloped. And here's the peak rainfall. And so we have a shorter time. And so this is more flashier. So the term flash floods, kind of that is sort of the terminology there. And then overall, there's a higher peak runoff rate. So this is the runoff rate compared to this one. And this can have a lot of downstream effects. Typically, our approach historically really has been to get water offsite as soon as possible. 100 years ago or so, particularly here in Florida, mosquitoes and malaria were big concerns. And so getting standing water offsite quickly and not having standing water around was a pretty large objective. And it was a pretty major objective around the US, just trying to get water offsite as soon as possible. Well, that change to the hydrograph, that increase in the flow rates can have some pretty big effects on the landscape. I just want to point out before I move on that, if we look at sort of the connectivity here, we have sort of, the rooftop that goes to the scuppers, the drains, then they go into maybe the street that goes into the storm drains here. And then oftentimes those will go into stormwater pipes that go to the nearest water body. And so that's basically trying to effectively get that offsite as quickly as possible. Now, the increase in our our flow rate, that peak runoff rate, would essentially start to erode out channels. And these are some images that I've collected over time of different examples of urban erosion. And this essentially wipes out the biology and the ecology that's in streams by essentially eroding out the channel. Anything that's living on the channel bed basically gets scoured out every time there's a storm event. But it also creates issues with utilities. You see in the upper picture, a younger version of your speaker from about 20 years ago in a stream underneath a pipe where essentially the channel has cut down and eroded that channel and washed out. Those steep banks will eventually start to collapse in. And you can see an example of this in the right-hand corner here, where a friend of mine, Mitch, is about 6'4", and he's standing in a former ag channel where urban development basically was all around it and stormwater was flowed into it. And so it's about 15 to 20 feet deep and maybe about 6 to 8 feet apart. So those banks are going to eventually collapse and erode in that site area. But stormwater doesn't only have a volume and an erosion risk, it also can carry with it a lot of the pollutants that are on our landscape. So for example, in the upper right-hand corner, roadways, we get the breakdown of brakes and other emissions from our automobiles, washing off metals and polyaromatic hydrocarbons. On our parking lots and our impervious surfaces, we accumulate sediments and the atmospheric deposition of nutrients, nitrogen specifically, and then organic debris, leaves, grass clippings, if you will, other types of organic debris. And if we're not responsible with the application of fertilizers on our landscape, those can make their way onto our driveway, sidewalks, and so forth, and be washed off in between by those storm events. And then I'd love to say that my dog was this cute, but he's not. But you can see the picture of the pet here, and essentially they are, walking, barking point sources of pollution that, when they go to the potty, they basically put out a source of nitrogen, phosphorus, and pathogens that we need to be essentially, picking up after them, or that's going to make its way into our water bodies in one way or another. When we think about sort of the overall impacts of urbanization, cumulatively, we have, the erosion that you see in the bottom left-hand corner. In the lower right-hand corner, nutrients that come from stormwater runoff can contribute to algal blooms and red tides. I think this is from the St. Johns River from maybe a few years back. And those can lead to degraded ecological environments where we have closed beaches and also we have fish kills. And just the impact of stormwater overall, when all this water comes to one place and we're basically everybody's trying to get it off site as soon as possible, there's typically somewhere that is the pinch point or the point that receives all that water. And if that's not designed, that can end up being essentially our streets and roadways, particularly when we start to think about our coastal communities with sea level rise and the impacts there. So we can have localized flooding on a regular basis. So with the increase in urbanization, we can see this at a large scale, that essentially our impaired waters or our water bodies that are not meeting their intended quality for fishing, swimming, or drinking water, or whatever the criteria is, oftentimes there's a correlation with urbanization. And hopefully you can see on the left, this is a map of urbanization in Northeast Florida. And then on the right, we have a map of the watersheds that are impaired. Now, urbanization is not the only cause of impairment on our water bodies. Some of that is due also to nutrients and pathogens that come from septic systems and also agriculture. That can also contribute large nutrient loads. However, stormwater is one of the main ones that we need to look at. And actually, if you kind of squint your eyes, what I was trying to have happen here is that you can kind of see the overlap between the urbanized areas and the impaired areas on the left side here. So stormwater management has come a long way, and there's been quite a history with how our goals and objectives have changed, and the science of stormwater management. It started out, as I kind of alluded to early on, was flood mitigation. We wanted to basically get water offsite as quickly as possible. Now that works for everybody that has the ability to send water downstream, but if you're the one at the bottom of the hill, you could be the one who's getting flooded out. And so there's been a lot of work on trying to address that. Over time, our goals and objectives with managing stormwater have kind of evolved, particularly the Clean Water Act and the NPDES regulations that came along have had a big impact on how we manage stormwater. If you remember the Cuyahoga River fire, this was an impetus for really the Clean Water Act that happened about 3 years later in 1972. The Cuyahoga River was an industrial river, received a lot of pollutants, and I think they were doing some welding on this bridge or another bridge. And this was not the first time that the river had caught fire. It had caught fire many times before, but this was one time where it was extremely large and maybe the most significant fire that they had had. And it really caught the nation's attention, and it really united much of our elected leadership to work together to address some of the issues of environmental degradation in our country. So the Clean Water Act, which was actually called the Federal Water Pollution Control Act, was passed in 1972. And basically what they tried to do was essentially focused on a lot of the point sources of pollution. So anything that was not permitted to discharge to surface waters needed to have a permit or be prohibited from discharging. And the goal was essentially by 1983 to protect aquatic life, human contact, basically make all waters fishable and swimmable by 83. And they wanted to eliminate the discharge of all pollutants by 1985. So that was an ambitious goal that we have not met even maybe 40 years later. But we are continuing to still work towards that. In the 1990s, there was a shift, particularly with stormwater, from considering it to be a point source or not being covered by the Clean Water Act to having it become basically under the authority of the Clean Water Act. So stormwater then had to be managed similarly as any other permitted discharge. And because many municipalities manage those, the authority for the Clean Water Act and stormwater management was delegated to the states. So the overall program that all of this kind of goes under, whether it's permitting discharge of pollutants from industrial sources or stormwater management, is under the National Pollutant Discharge Elimination System, or the NPDES program. Okay. So if you ever hear of NPDES permitting, so this program essentially was created as part of the Clean Water Act. And initially, as I mentioned, kind of focused on the point source. So the point source is where you can identify an exact point where the pollutant comes in, right? And so essentially, they delegated the authority to the states for industrial pollution. Wastewater was considered here, as well as municipal stormwater that was being discharged. And really kind of, kind of answered the question, can I send runoff into the stream as long as it doesn't hurt it? Well, it's not stormwater doesn't come from one place, it comes from an area. But it does, oftentimes get collected and discharged into a single point. And so this was kind of the debate about whether the Clean Water Act applied to stormwater up until the 1990s. And so we have this program called MS4. So if you ever hear someone talk about the MS4 permit for a municipality, this stands for Municipal Separate Storm Sewer System. Okay, so it is basically the storm drain network that collects the storm water and discharges it or conveys it to any water bodies. Okay, and the interpretation that applies here is that once stormwater runoff leaves the surface and enters into a stormwater pipe or storm sewer system, it then becomes a point source wherever it is discharged. So then it has to be managed and maintained and addressed and permitted as such. Some of the terminology, just to kind of point out here, one of the most important ones that I'll show in a little bit further in a moment is separate. So sanitary sewer systems, that's our wastewater, is in this case is separate from the storm sewer systems. Now, there are some municipalities where they've had combined sewers, but that does not apply here. It's only looking at stormwater runoff. It's only looking at what's in the storm sewer, and it's looking at what's in the overall system. So just to kind of touch on this as far as the terminology and understand what's going on, combined sewer overflows is a term you might have heard. And in this case, they basically, the storm sewers and the sanitary sewers are kind of combined here. And so during dry weather, when there is no stormwater running through that network, the water flows from the municipality to the wastewater plant and gets treated fine. When there's a rain event, the stormwater enters into the system and then causes that to discharge not just the runoff, but the untreated wastewater into a water body. It overloads the system essentially. Now, we still do have sanitary sewer overflows that occur here in Florida from time to time. Typically, when there is a clog in the sanitary sewer, or there is some type of a failure at a wastewater plant, for example. And in this case, it'll often happen when there's leaks in the manholes. So if there's flooding in a street, that water can build up and then enter into the sanitary sewer, overloading that and causing it to discharge or overflow. Okay. But in Florida, the way that we've kind of gone about addressing much of our stormwater needs, particularly the initial regulations, the way it was implemented, has been through the implementation of stormwater ponds. And here's sort of just a good example showing sort of the transition of an area. And I think this is from either Manatee or Sarasota County. And I just, notice the river here as sort of your point of reference. We've got all these sort of, natural depressional ponds here. And this is what this now looks like as an urban development. And we see that stormwater ponds are essentially everywhere. They're very prolific around the state, but they're not all the same. You notice they have different sizes, shapes, and different characteristics. Some of them only collect runoff from the landscape. Some of them receive runoff from other ponds, and they're connected. And then some of them are the ones that actually discharge to the water bodies. I think this is the Braden River as it comes through here. So I want to talk a little bit about the different types of stormwater ponds that we have, just so you understand the differences. So these terms retention and detention are often used interchangeably, and they're not the same. And the way I try to remember this is through the school analogy. I don't know if y'all were well-behaved kids in school. I was not. I'll be perfectly honest. And I'm getting payback by having 3 kids of my own who are going through school now. So I understand, and everything that happens, I have coming to me. All right. But anyway, that means that I was often held in detention. All right. Which means that I essentially was held after school, but I was eventually released. So that's what detention means. It's basically it captures, holds it, and then releases it, typically slower than it comes in. Retention is a little different. So if you think about retention in school, this was when essentially we didn't pass the grade, right? We were retained in that grade and we had to do it over again. So it does not move on. So essentially water comes into a basin or a pond, and that water essentially is held on site. It does not leave and go downstream. It basically infiltrates into the ground, either laterally or vertically. So on the left here, in the upper left-hand corner, we have sort of what is called a dry retention. Water comes in, it fills up the basin. We have this in very well-drained sandy soils where the water basically goes down and then infiltrates or percolates into the ground. We do have what's called wet retention, which is down below, where it maintains a constant water level. And in this case, the water, instead of infiltrating vertically, will actually infiltrate laterally. Now, the time it takes for that water to go down is usually much longer than it would be if it was a dry basin. Okay, so we do have this lateral flow. With detention, We don't have many dry detention anymore because of water quality or the lack of water quality benefits that dry detention has. Essentially, water comes in, fills up, and then it basically slowly releases or discharges out downstream. With wet detention, which is oftentimes what we see, we have water that typically comes in and then slowly discharges, but it comes back down to a permanent water level. Now, we do have a little bit of combination of function that happens with these ponds where you can have a wet detention on the bottom right, and it also do some retention where that water basically passively infiltrates laterally into the subsoil. That definitely can happen. And if we have a mounded water table or the infiltration gets all the groundwater comes up to the bottom of the basin, then we can actually have a retention pond that kind of functions a little bit more like a detention pond. Okay, that can happen in some cases. But if we're looking at just our stormwater ponds, our wet stormwater ponds, we've mapped that there's about 76,000 of these. Actually, that's probably a pretty conservative estimate because that was based on 2016 numbers, and now we're about 8 years past that now. But you can see that stormwater ponds are all over the place. And if we look at, they're basically wherever our urbanization is. It is the most common practice for managing our stormwater runoff. And if we look at the overall land use in Florida, we see that stormwater ponds take up more area than even industrial land use. And so it's a lot of our state. I think it's somewhere around 1 or 2% of the total land area in here. So why do we have so many? Well, like many things, it has to go back to the regulations, all right? So developers are required to mitigate for any post-development impacts to water resources. This is through the Environmental Resources Permitting Program, or ERP, that is managed by each of the water management districts. So they have to address the flood risks and the nitrogen and phosphorus loads that are coming off of the developed area. Stormwater ponds are a pretty easy option if you think about it. There is a source of fill material. So you basically excavate the pond and then you use that material to build up the lots around it. And it's an efficient use of the material. You don't have to import soil. You don't have to find some other place to move it or send it. It sort of balances out and it's cost effective. They're efficient use of space, so they're oftentimes fairly compact and restricted in size. And they do get credit for addressing both flood and nutrient loading. I'll talk a little bit more about that later on. But these are an easy option, and there's little incentive until recently to use other approaches. One of the issues is that there is a presumption of compliance with the water quality standards. And what that means is essentially there were some criteria set up where based on if a stormwater pond could remove 80% of suspended solids, back when it was a lot more difficult to analyze for phosphorus and nitrogen, we would assume that that pond would also remove 80% of phosphorus and nitrogen. Okay, so kind of the assumption being there, well, a lot of our nutrients are particle size or are attached to soil or sediments. And so if it can remove 80% of that suspended sediments, we can transfer that assumption over to phosphorus and nitrogen. We'll get back to that in a little bit. That's sort of where we're at, though. So the way that detention kind of works, if we go back to our stormwater runoff and the impacts of urbanization on our runoff rates, we see here again our rainfall. We call this a hyetograph. You can see maybe in the background our pre-developed runoff curve, and notice that this yellow dashed line is our pre-developed peak discharge, and this red one is the uncontrolled developed runoff curve. One of the main things with detention for setting how slowly water needs to be released, we go back to some of those erosion pictures. It's really looking at what is the historic discharge from that area and basically reducing that runoff from the developed landscape and extending it so that it doesn't exceed the pre-developed peak runoff rate. That's sort of the goal there, and it ensures, or kind of at least provides some level of confidence that we won't lead to downstream erosion, okay? It also helps to reduce the chance of downstream flooding, because not everybody's discharging all the water they have at one time. Everything's kind of slowly bleeding out, typically over up to about 3 days. So our conventional approach has kind of been to essentially take our runoff from our lot level. This is when this is essentially non-point source. All right, it then goes into the storm drain, enters into the stormwater collection system, and then we send it to a stormwater pond where it performs the functions of flood control, flow rate, and water quality. All right, and to where that water is either, if we have a really large storm event, we might have overflow. If we have a smaller events, then it may just be discharged, and that might be the only flow that comes out of the ponds. We often see that these stormwater ponds are, concentrated around the edges of properties or developed areas where they're kind of out of sight, out of mind, to be honest. And that kind of gets to some of the maintenance aspects that we need to keep in mind. So one difference that I want to point out, particularly when we think about the understanding our ponds and understanding what's happening with them, is to know the difference between an online and offline pond. So with an online pond, stormwater for small, regular, everyday storms comes in and it fills up the pond, and it has the slow bleed down discharge, right? So water comes in and then it slowly drains out. If we have a large storm event, that heavy flow comes in and the pond rate rises up, water level rises, it overflows through the outlet, and we'll see sort of some examples of these concrete block storm drains. And this is sort of the emergency overflow where water can bypass or overflow the system. If the pond is offline, this usually looks like it only has one inlet. But in reality, it's just it's a two-way flow that occurs here. So water can come into the pond for low or small storm events, and then it infiltrates, or if it stays there and evaporates, or however it's managed otherwise. During large storm events, the large volumes of water will come in, it will fill up the pond, and then once it reaches a certain level, the excess flow will then bypass the inlet so that no more water can go into that pond, okay? So that water continues to flow past the inlet there, and it is essentially offline, okay? So some of these structures to keep in mind, if you see these out in the environment, these are really important to maintain. These are inlet and outlet structures, and they are extremely important to, number one, make sure that they are structurally intact. So if you ever see cracks or that this is failing and you're maintaining a stormwater pond, that needs to be reported to the property owner ASAP, because that can, if there's a large storm event particularly, that can cause a structural failure, could cause the system a blockage to occur, and cause some unintended flooding in other places because of this failure. It's important to keep these clear and free of debris. You see the metal sort of grate that goes around some of these. This is intended to keep back floating material so that it doesn't deposit on the surface of that overflow. So think of like leaves and vegetation that sometimes is floating on the surface of the water. We don't want that basically caking over on the top of the grate. I've seen that happen, and it's pretty impactful how high the water can get and how overflow can occur and cause erosion. But yeah, the main thing here is just to make sure that these are maintained structurally intact and that there is no debris clogging them. Okay. If you are maintaining a stormwater pond, or you're responsible for it, and you're having trouble kind of identifying what's going on, or the configuration, or how it's supposed to work, you can usually find the as-built engineering plans on the Water Management District website. It's a little bit tricky to go through, but you basically, oftentimes they have a GIS or a mapping interface. You find sort of where the pond is, you find the permit number, and then look for the design plans, and that will give you the you may have to go through some of the plan sets to find out where the pond that you're interested in is located. But then that will give you some information about the connectivity. I'll go into that a little bit more later on. But that's sort of where a lot of times these plans are found on the ERP, or Environmental Resource Permitting website of the Water Management District. So let's talk a little bit about the stormwater pond itself. This is our typical wet pond, stormwater pond, where we have essentially a deep zone, a littoral zone. We have the slope or the edge of the bank. These are sort of the main areas that we're going to deal with. So the deep zone this is the most familiar feature of the stormwater ponds, and it holds the greatest volume of water. The littoral, some people pronounce it littoral. I think that's littoral is spelled a different way, and so this should be pronounced differently, but that's neither here or there. I hear littoral most often, is a less common feature of stormwater ponds, but this is sort of a shallow area that's extremely important to maintaining healthy ponds. This is a lot of times where our shallow water vegetation, where it can basically plant it in saturated soil but extend up above the water surface, helps to improve water quality. These plants help to protect the banks from erosion, particularly wind-driven tides, or not tides, but wind-blown energy, wave fetch that can impact and slowly erode the edge of stormwater ponds. So that vegetation helps to dampen that energy. And then the slope, this is that perimeter area around the pond that is typically between the surrounding landscape elevation and the water's edge of the pond. And these are all important aspects to manage. One of the aspects here is really looking at sort of that interface of the slope. A lot of times we recommend that we have a no-mow zone around the edge of the pond. As you see here in the bottom right right photo, this allows vegetation that is a little bit larger, particularly in the area or the section of the slope where the water level will rise up and it may be exposed to that wind wave energy. It allows those plants to absorb that energy and prevent erosion from occurring on the slope. It's also a good practice to have vegetation right at the edge or the bottom of the slope. And if I had to choose between them, I would say that the bottom of the slope is more important, because if you can eliminate the energy at the bottom of the slope, then you can eliminate the erosion that can occur at the bottom of the slope, and is usually the starting point for erosion that works its way up the slope. Okay, so getting good solid vegetation around the edge is a great way to improve the water quality, as well as keep the erosion down. So the littoral shelf, this is sort of a transition zone where we have between the deep pool and the pond. You can see we have sort of a range of vegetation at different depths. So there's a wide range of plants that are available within this littoral zone that we can plant, and a diversity of plants that can be brought in for habitat. And you can see that there's, a lot of different plants that can come in here, whether it's, things like pickerweed, bulrush. These are oftentimes wetland plants that can actually add a lot of color to the aesthetics of the pond and help with preventing that erosion. When HOAs particularly have erosion issues for putting in, and they look at sort of the cost of repairing that with like a silt tube or some type of retaining wall there, it's oftentimes on the order of $100 a foot. So it can get very expensive to repair this, and a little bit of investment early on will go a long way in the long run. And lastly, sort of the deep water zone. This is a really important area. Really, when we think about managing a stormwater pond, we should think about it from this aspect of a fish tank, right? When we think about monitoring and managing a fish tank, we don't just address one particular aspect of the fish tank. There's a balance that needs to be put in place within that tank. All right, we add food to the fish tank, the fish eat it, and it excrete nutrients into the water. There is a filter that helps to remove those nutrients. If there's too much nutrients, then we start to get algae. So that we try to adjust it and keep the organisms and ecosystem in balance. And that's how our approach to stormwater ponds should be as well. And so these deep water zones can be great for supporting habitat of fish that can help to manage algae as well as provide diversity of habitat in this environment. I also want to say that, stormwater ponds that have algal blooms is not necessarily a bad thing. We don't like to have severe algae blooms, and that can be maybe managed by trying to reduce the nutrients that are coming in. However, small amounts of algae or slight coloration is pretty natural. We want the algae, if it's going to take up nutrients and process nutrients, to do it in the stormwater pond rather than in the downstream water bodies, right? We're not intending for these stormwater ponds to be natural lakes that are clear water systems. These stormwater ponds are intended to treat water, okay? One of the other aspects that really affects how well a stormwater pond functions is the shape. You can see there's a wide variety of shapes in stormwater ponds. And one of the main things here is that oftentimes the ones that have sort of a longer, narrower shape will perform better because they allow the water to stay in the pond for a longer period of time, and that residence time that it's in the pond helps to improve the water quality and treat it more effectively. You can see that, we see a diversity of plants in these ponds, and those plantings can help with preventing short circuiting, where water comes in and then flows directly to an outlet and really doesn't get treated very much. Okay, so including plants to help with the design or the ratio of the length to width can help with the overall functioning of stormwater ponds. And one of the exercises we'll sometimes do is asking folks to look at these ponds and sort of compare which one, and I apologize, the A is a little bit offset from the long, narrow pond on the left there. But looking at these three ponds, which one has the best sort of length to width ratio? And hopefully you can see that the A pond would be the longer, narrow one that would have a longer duration residence time in the stormwater pond. I brought up the design plans before, and just wanted to touch back on that to kind of look at what the configuration, what kind of information you can find from these ponds are. Just to kind of clearly show it, here's the roadway of a land development here, Sandhill Preserve Drive. We have lots here that are graded to the front and the back. And then here's our stormwater pond. We see it, it's called Lake number 4 here, but it's our stormwater pond. And then here is it looks like an overflow device, essentially a berm where water can, at a high level, overflow. But essentially, this is our stormwater pipes, the inlets that are coming in here, and we have an inlet that's coming in here as well. So understanding where that water comes from, being able to identify these pipes and inlets can be very important. Particularly if you see here, these pipes are extending beyond the edge of the pond. Many times with our lack of elevation, we will see that these pipes or the inlets are actually submerged, and that can be fairly difficult to identify in the field if the water is deep and dark. You may not be able to visually identify it there, okay? But a couple things to keep in mind with these systems here. Number one, these can be found at the Water Management District, typical for your stormwater ponds. Some of the helpful information are, the extent of littoral zone. So if you can see sort of here's our littoral zone hatching, and we have it on this sort of the roadway side of the pond back here. It also indicates sort of what the normal water level is, or how high the water is supposed to be, what the elevation or top of bank is, and it locates where those structures are. You want to make sure that those inlets and outlets are free of sediment, vegetation, and any structural breakage. A lot of times we can see where there's erosion, actually not where the pipe discharges, but actually slightly up the bank from it, where there might be a joint between the pipe and the flange edge, where there's a gap that water can actually move through and it erodes down through it. So essentially making sure that there is free flowing capacity in the pipes and into the pond. Now, I'm running a little bit short on time, but I do want to touch on this aspect. I might go through these last slides a little bit quick. So stormwater ponds are not the best at removing nitrogen and phosphorus. I mentioned before, they're assumed to remove 80% if they capture a certain volume. The problem that they have is that the type of nitrogen that comes in particularly really reduces the removal efficiency. So if you see here, this is the detention time or the residence time for water staying in a pond. And essentially, it only removes about 40% of the nitrogen that comes in after only a few days or a short duration. Here's our 80% goal, and we never meet that. So we peak at about 44% removal here. The reason is because much of the nitrogen that comes in, or this fraction, about half of it, is in a particulate form. So remember back to sediments being the basis for our nutrient removal criteria. Well, we do have some of that nitrogen that does fall out, but it's only about 45% of the nitrogen that comes in. The rest is the dissolved nitrate and ammonia and organic nitrogen that stays suspended in the water column and doesn't really transform or get removed at any point. Now, phosphorus will essentially be reduced sufficiently after a long period of time, but oftentimes our detention times are not quite this long. This just kind of shows that the breakdown of about half of our nitrogen is in some type of a settleable form, and this is sort of our dissolved form here. And nitrogen's kind of complex. It takes a lot of different processes to actually remove it. And so we need to kind of match the pollutant removal process with the forms of nitrogen. And that's kind of hard to do in one place. When we think about the rainfall, a lot of these stormwater ponds are also designed for these really large storm events. So for example, I highlighted the red, orange, and yellow here. These are our 25, 50, and 100-year storm events that are 24-hour duration. This is for Jacksonville, so it's just a representative location. But you see that this is 8.6 inches of rain, 11.8 inches of rain. These are large storms. These are like hurricanes. These aren't supposed to be happening on a regular basis. But this is the size of storms that our stormwater ponds are designed to manage and maintain. If we look at the overall distribution of rainfall, though, the number of storm events, notice that this doesn't even get up to 8.6, really, because those storm events are so much higher, it's off the scale here. What we see is that about 87% in this case, close to 90%, of storms are less than an inch. And so it's actually the frequent rinsing off of the landscape, what we call the first flush, that contributes more of the pollutants into our water bodies, into our stormwater ponds, than those large storm events. So the real problem or issue or challenge that's occurring is that we have a lot of pollutants being washed off on a regular basis, whereas the stormwater ponds are really designed for those infrequent, rare, large storm events in most cases. So overall, a lot of our stormwater issues are continuing to be an issue. We have an issue of legacy stormwater regulations and stormwater impacts. Nationally, stormwater is the second leading impairment to coastlines, second to bays and estuaries, and fifth most common impairment to streams and rivers, and eighth for lakes. If we look at the percentage of impairments in Florida, we have 31% of coastlines are impaired, 59% for bays and estuaries in Florida, 55% of streams and rivers, and 80% of lakes. And when we look at sort of what the cause of these impairments are, we see that nutrients, algal growth, low oxygen, pathogens are some of the main causes of impairment. in these water bodies. And so these are not necessarily all coming from stormwater, but stormwater does contribute to these impairments. So recently, in the past few years, there's been an effort to update the stormwater rules. And I'm pleased to share that this has finally passed the legislature to ratify these updates to the stormwater rule. One of the main changes that will go into effect eventually is that the water quality requirements for stormwater ponds or stormwater management are changing from this technology base where we have a presumed performance, that presumed 80% removal that was really around 40% for nitrogen, that's going away. And it has to be now a performance based. So now stormwater ponds would only get about 45% nitrogen removal credit at maximum. So the aspect there is that we won't be able to just do stormwater ponds now. We'll need to do additional practices upstream, which are things such as low impact development, green stormwater infrastructure. So the rates and reductions for nutrients are going to be, we're going to have to use additional practices to more effectively address the nutrients to meet these criteria for the stormwater ponds, or I'm sorry, for land development. So I know we're really short on time, and I see there's some questions in the Q&A and chat. So I want to leave time for it, and I've got time after this to continue long if folks want to stay on. So I'll take any questions. I'm going to let Claire kind of direct the questions to me, and we'll kind of manage it that way. Does that sound all right?
Sounds great. Thank you, Evan. That was really, really a good presentation. I learned a lot in that.
Thank you.
And there have been a number of questions and some great chat going on where people are answering each other with some good information. I've tried to group some of these questions together, so I'm just going to kind of go down the list that I have here. And the first one I have is there a way to determine a city or neighborhood's impervious percentage?
You can, yes. So a lot of times, many municipalities are moving towards having an inventory of impervious cover on the local GIS, Geographic Information System website. And that's oftentimes something that can be accessed publicly. So that's probably the best way to do it. And using that kind of software can be probably the most direct way to do that.
Awesome. Kind of in line with that, is there a ratio or scale to determine the size of the stormwater pond?
Ratio or scale? I'm not sure with
I think they're talking about holding capacity of the pond. Like, how do you determine how much water?
Oftentimes you try to take whatever the amount of water is that it's capturing for water quality or for flooding. You typically, well, for water quality, it's typically held in the top in a foot of depth above the normal water level. For flooding, larger storm events, that can go much more above that. And that could be up above. You could probably see if you look at the outlet structure, if it has like an elevated sort of concrete with a grate on top, that's probably a good indication of sort of your high. That would be the highest that your water quality or your normal water level would go. And it should drop back down to where there's kind of at the bottom of that metal grate that goes around it. We call it a skimmer because it kind of just skims off the top of the water surface there to keep vegetation from clogging those low flow orifices.
Great. All right, let me read this one. If a system is discharging over 3 days, is there a point where the assumption of keeping peak flow at or below pre-development levels breaks down? For example, as we are now getting more frequent, more intense rain events, is the design engineering math keeping pace? What happens with systems designed 10, 20 years ago in regards to discharge liability for point source pollution?
Well, that's a great question. And it is a lot of these structures were designed and installed with rainfall records from, let's say, the 1960s to the 1990s. We usually use a 30-year record. And that was an assumption that that was going to be the same pattern for, forever. We have now understood that this is not a stagnant, unchanging weather or climate. And so, no, many of our regulations have not incorporated adjustments for climate change. Me and several colleagues from American Society of Civil Engineers actually just put out a paper making recommendations for different ways that municipalities and the public needs to start incorporating adjustments for the projections of climate change to rainfall records and how different communities have done that. It's still pretty a large minority of jurisdictions are doing that, but it's something that needs to be taken into account. I don't know from a legal aspect how that would be addressed if they could. I'm just not sure. I'm not a legal expert on this aspect, and that would be a tough one. They were following the standard practice for engineering when they designed it. So I think there's a coverage, or they were doing what was the standard practice at the time. Out of their control if things change,
Yeah, that's a tough, kind of sticky one.
I can try that paper is open access. That I could put that in the chat if folks wanted to.
Oh, wonderful. So that's published already, and we can, I would like to include that on our website too, so people can find that. So another question is, do ponds need to be dredged?
So they can, if they get enough sediment in them where their storage and pond volume is reduced substantially, then they do need to be dredged to remove that material. If that material can be tested to determine whether it's toxic or not. If it's not, in most cases, it's probably not going to be, unless it's in a what I might call sort of a hot spot that has metals or other toxic things in the landscape that's running off. If it's not toxic, it can be landfilled or used as fill material other places. Yeah.
And kind of along lines with that one, it seems like chemicals like fertilizer, pesticides, insecticides, herbicides, etc., end up in either the stormwater pond or directly sent to a water body. With a stormwater pond, either online or offline, do all these chemicals build up over time? How do stormwater ponds avoid becoming toxic? I sometimes see people fishing in stormwater ponds and not sure that they eat the fish. They may just be catching and releasing.
Yeah, that's definitely it's a concern. So yeah, this would, these contaminants from the landscape do build up in the pond sediments, particularly. If it's nutrients, plants can take that up and other organisms can cycle those nutrients. Nitrogen, if there's if there's the right conditions and the nitrogen's in the right form, it can be denitrified, and we can remove it that way. But overall, there is sort of this long-term buildup. And that's one reason that, a lot of times we try to discourage using something like copper sulfate on a frequent basis in stormwater ponds, because that will kill the algae. But if you're using that on a regular basis, it's likely going to build up in the pond. And so that's not a good thing for the environment or for the sediments. And if you're fishing out of these ponds, yeah, definitely there's risks with whatever's been accumulated in that pond. The fish have kind of been living in there, and their toxics could accumulate in them. I would not recommend eating anything out of a stormwater pond. They are not, like I said, they are not meant to be pristine lakes. They are meant to be treatment ponds. So yeah.
Let's see. Is there an annual progress report published on the progress made towards fishable and swimmable 1983 goals?
I don't know that it's annual anymore. It used to be. I think it's more like every 5 years now that it goes to Congress, and Congress has to approve it. They do update the list of impaired water bodies I think they do that on an annual basis. Each state reports that to the EPA, and that may go to Congress as well. But yeah, I don't think there is a enclosed report or updated database that comes out every year, so to speak.
Okay, I've got another question that's a little different. It would be so good if homes were built to have drains running from rear gutters into stormwater and other ponds. The lack of these gutters from the developer is costing residents thousands of dollars to build up the erosion into the ponds and now install the gutters. And I thought maybe you'd like to address, water directly being directed into the stormwater pond versus running across the.
Yeah. Okay, so there's a couple of different ways that we could look at this. Number one, from a lack of erosion standpoint, yes, there's the water coming off of the rooftop, if it's collected in a drain and can be piped to the pond directly, that would likely prevent that erosion. However, you're not going to number one, you may or may not capture all the roof runoff. During heavy storm events, the water that often collects between the houses can be quite heavy, and it may be overland flow anyway, and lead to erosion. So it may not be capturing all of the water there, particularly if you have a heavy rain event. That pipe may be overwhelmed by the amount of water coming off the gutter. Now that water is fairly clean relative to what might come off of a roadway or a landscape from a pollutant standpoint. So I don't have an issue there. But by having it flow, not giving it an opportunity to infiltrate as that water flows over the landscape, you are adding additional volume to the pond. So it's kind of I would advocate let's try to keep water in the landscape and infiltrate and use the landscape in that way as much as possible to promote infiltration. And I mean, I think the main thing is trying to, whenever we concentrate flow from gutters and the downspouts, there's a lot of energy right there. And it's really important to dissipate that energy, whether it's by fanning it out with a spreader, or maybe even putting some stones there just to kind of provide the reinforcement so that we don't have erosion occurring. Any way to kind of dissipate that energy or kind of diffuse flow is going to help reduce the occurrence of erosion. But yeah.
So thank you. That was a good explanation. I've got a couple questions here that relate to planting around the edge of the pond.
Okay.
And one deals, and I'm going to tell you them both because I think you can answer them probably together. One kind of deals with, how do you convince your neighbors and your HOA to let you plant around your pond? And the other one I'm going to read. As a design professional, I find it difficult to convince our clients to buy in on anything beyond the minimum that is required, such as green stormwater infrastructure and LID. I even face this difficulty on projects for groups like UF, as the project budgets are typically constrained. Do you have any advice there encouraging the cultural change around the ponds?
So there's several questions there. One, the vegetation around the stormwater pond. We run into that a lot. There's a perception people love to see water, right? I mean, that's why the homes that are sold on stormwater pond, adjacent to stormwater ponds, are sold as waterfront property, and that's not wrong. It's not lakefront, but it is waterfront, and people like to see water. There's also a segment of the population, particularly my wife included, that does not like to have tall plants that could have a habitat for unwanted wildlife, such as snakes and so forth. But same aspect. I mean, we are in Florida. Alligators are part of the ecosystem here. I mean, it's one aspect that kind of, there's what you're signing up for in a way. But the vegetation, I think a lot of it is helping people see what it can be and seeing how colorful and how much it can enhance. The other thing is that you don't necessarily need to have continuous vegetation around the littoral zone. There can be sort of these windows, I think is what they're called, where they have these breaks in the vegetation where you have more of a direct connection with the water. But I would also, it always comes back to money too. So it's a lot cheaper to put in and maintain plants around that littoral zone than it is to put in $100 a foot piping that basically stabilizes the erosion there. So that's I would go with that argument and just say, look, there's plenty of examples of those types of stormwater ponds where the bottom, the toe of the slope just starts eating away. And you have this sort of drop off an edge, and it doesn't show up maybe for 10 years, but then 10 years in, it's becoming a problem, right? So yeah. Aeration can help with stormwater ponds by adding oxygen to the system and oxidizing ammonia to nitrate, which can help with nutrient uptake and cycling. It also helps water not to be stagnant. So yes, it can help it.
And if you don't mind, I'll add on a little bit with, how to encourage the green stormwater infrastructure and LID. And there's a lot of grants available through DEP trying to encourage the implementation of GSI. So, reaching out to Dr. Bean or myself, we can kind of help guide you to the right people to talk to at DEP if you'd like that. Because, certainly those monetary incentives can help a community.
I just put a link to an EDIS as well it's a EDIS that several of us put together, trait-based selection of stormwater pond plants for different zones of the stormwater pond. So if you want, aesthetic, if you're looking for erosion control, if you're looking for other features, this kind of is meant to kind of help with that. The other thing I was going to say is that, we're not going to be able to, in new developments, just do stormwater ponds from here on out. The new rules that have been implemented are going to restrict that. Or basically, you're not going to get a permit for just doing stormwater ponds. You'll have to do something additional because stormwater ponds are not going to get you to your nitrogen removal credit. And you need to there's going to be green infrastructure that will be essentially your only option, or other types of design features that will have to be there. John, look up four posts from from where you put that.
Okay, and I see Emily Lang, who is our DEP guru. She responded in the chat box too with a direct link for DEP grants for green stormwater infrastructure. So we are running over. I was, if you don't mind, I was going to ask one final question here.
No, that's fine. I've got some time.
Yeah, it's John. And since trees significantly impact stormwater, I'm curious to know if there are any specific measurements that can be utilized to minimize developers' stormwater requirements by preserving trees. And I'll let you answer that.
Can you read it one more time?
Oh, yeah, I'm sorry. Yeah, I kind of
just want to make sure.
Since trees significantly impact stormwater, I'm curious to know if there are any specific measurements that can be utilized to minimize developers' stormwater requirements by preserving trees.
Yeah, that's a great question. So canopy interception is the kind of the function that trees can have on stormwater runoff or reducing runoff and reducing the effective rainfall. Oftentimes it's not directly credited with, okay, we're saving this amount. What it's sort of implicit in the developed area. So if you reduce your developed area, you are reducing your disturbed area. So the amount of runoff that you have to manage and that you're responsible for goes down. And that's essentially some of the principles of low impact development, which is looking at, okay, what does the site offer? What is the amount of area that actually we actually have to clear and utilize for the purposes of the site? And where can we do more compact design? Where can we cluster development? How can we take advantage of the existing hydrology and drainage of the site rather than, forcing it to be something else? How can we have the design meet what the site offers rather than forcing something onto a site that happens so many times? So I think that's kind of maybe a short and sweet kind of a way to address that. Most regulations don't specifically give credit for trees. There's a mechanism of penalty. The number of trees that you take down, you have to replace, and the size of the trees and quality and so forth. And that's usually in local regulations, the tree removal as part of permitting and so forth.
Well, thank you so much. Yeah, this area is really growing and expanding, and it's exciting. It's an exciting time to be in this field. I really appreciate your presentation, Dr. Bean. This was very informative. We have there was a lot of engagement in the chat box, and people saying thank you. So with that, it's 11:10, and I'd like to conclude this webinar today.
Sounds good. Thank you.
Thank you.